Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to generate a frequency distribution using STATCRAFT. Even before I proceed to demonstrate how to generate a frequency distribution using STATCRAFT, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing the dataset that I'll be working on. This dataset is called as the drugs dataset. There are 7 important fields in this dataset. This dataset talks about the patient's demographic details as well as the health details of an individual. The first variable here is age. Second variable would be gender. Then you have BP level and cholesterol level of the patient. Further, you have the sodium concentration in the blood sample of the patient and the potassium concentration in the blood sample of the patient. The last variable that you have here is the drug to which the patient responded to. Basically, there are 5 different drugs that are given to the patient. Each patient has responded to a particular drug. The drug to which the first patient responded to is drug Y. Let's look at the first record. In the first record, we are talking about a 23-year-old person. She is a woman. Her BP level is high. Cholesterol level is again high. The sodium concentration in the blood sample is 0.79 and the potassium concentration is 0.03. As I mentioned before, she has responded to drug Y. The same way you can interpret each and every record. One important question here is, what is the sample size in this data set? If I select all the cells, you can see here the count is 200, which means that in this data set, we have a sample size of 200 records. For most part of the analysis, I will be using only the last variable, namely drug of response. Now, with this background, I will proceed to STATCRAFT to show you how to produce the frequency distribution. As you can see here, this is the STATCRAFT software. This is a Make in India initiative. And I've already loaded the file which you saw earlier in spreadsheet. These are the 7 important columns: age, gender, BP level, cholesterol, sodium concentration, potassium concentration, and finally the drug to which he or she responds to. There are 2 ways in which you can generate the frequency distribution. The first would be through a graph and the second would be through a table. Let's first generate the frequency distribution using a graphical display. To produce any graph, the first thing that we do is click on the Analysis tab. Once I click on the Analysis tab, I can scroll down. Here you see an option which is called as Graphics. I'm going to click on the drop-down menu. Let me scroll down. You see here, there's an option for pie chart. Let me reduce the size and refresh this particular dialog box. What you're seeing here is called as the pie chart dialog box. You have a list of variables that we can use to produce the frequency distribution. Remember, frequency distribution works for a categorical variable. We don't take a scale variable when we produce frequency distribution. I'll go ahead and select the last variable called as drug. The variable drug is chosen under the factor list. Let me go ahead and choose OK button. STATCRAFT takes a couple of moments to run the analysis. You can see here, STATCRAFT has generated the output. This is the output of the pie chart. And you can see here the R code that is used at the backend to generate the pie chart. Let me scroll down. What you're seeing here is a pie chart showing the drug to which the patient responds to. The dominant slice here is for drug Y. This is represented by the purple color. What do we conclude from this pie chart? The one important conclusion that we draw is 46% of the patients have responded to drug Y. Nextly, 27% of the patients have responded to drug X. Also, we see 8% of the patients have responded to drug C. Again, 8% of the patients have responded to drug B. Finally, what you see is 11.5% of the patients have responded to drug A. So one major insight that we can extract from this analysis is that majority of the patients have responded to either drug Y or drug X. This is a graphical display of how you can see the percentage of patients who respond to each of the drugs. Now, we will demonstrate how we can produce a frequency distribution table through descriptives. To do this, let me go ahead and click on the Analysis tab. The Analysis tab is located at the top left-hand side corner. There are different options that STATCRAFT produces. The fourth option from the top is what is called as descriptives. Once you click on the drop-down menu, STATCRAFT displays two options. The first one is descriptives and the second one is frequencies. The option of descriptives is used when you want to analyze a scale variable. You can use the option of frequencies for any categorical variable in the data set. Since I want to show a frequency distribution table, I will go ahead and choose frequencies. This leads me to a new dialog box, which is called as the frequencies dialog box. In the canvas on the left-hand side, you can see all the variables that are present in the data set. I will choose the last variable for analysis. You can see here, the moment I click on the plus sign, the variable drug is selected for analysis. Let me now go ahead and select OK. Again, it takes a couple of moments for STATCRAFT to run the analysis. What we have now is the frequency distribution table. Interestingly, STATCRAFT also displays the R code that it has run at the backend to produce this particular frequency distribution table. What do we observe in this particular table? And in the column, you see four important items. The first column is frequency. Secondly, you have cumulative frequency. Thirdly, you have proportion. And the last column here is cumulative proportion. In the row, you have the breakup of each of the drugs that a patient responds to. When you look at the breakdown of each and every drug, you observe that 23 patients have responded to drug A. 16 patients have responded to drug B. 16 patients again have responded to drug C. Next, you can see here 54 patients have responded to drug X, and finally 91 patients have responded to drug Y. It is quite clear that majority of the patients have responded to either drug Y or drug X. The second column here is frequency. Sorry, it is called as cumulative frequency. When it comes to drug A, under the cumulative frequency, you can see the number of 23. This simply tells me the number of patients who have responded to drug A. When you add 23 to this number of 16, 23 plus 16 is 39. This number 39 simply tells me the number of patients who have responded to drug A and drug B put together. The same way, when you add 39 and 16, you get the cumulative frequency of 55, which simply means that put together, there are 55 patients who have responded to drug A, drug B, and drug C. Many times, we don't look at the frequency. Instead of looking at the frequency, we look at the proportion of patients who have responded to one of the drugs. The first proportion is 0.11, which roughly means that 11.5% of the patients have responded to drug A. Nextly, you can see 8% of the patients have responded to drug B. Again, the next number here, 0.08, says 8% of the patients have responded to drug C. This is how you can interpret the rest of the numbers. The last column here is the cumulative proportion. Just as we interpreted the cumulative frequency, we can use the same interpretation for cumulative proportion, except that STATCRAFT is displaying the cumulative numbers for the proportion column here. With this, I have come to the end of today's video. In today's video, we have seen how to generate frequency distribution using two methods. The first would be a graphical summary using a pie chart. You can also use a bar chart if you want to. The second would be through a table. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again, and have a great day ahead.